Hello, hi guys, welcome to the Chalk Talking Networking Technology. Let's discuss the TCP or transport layer in much more detail. Now, before we jump into the TCP protocol, I want to discuss this diagram in much more detail with you guys. So there is a sender. Let's suppose the application name here is FTP, which sends some data to here. This is client, which is receiver. Now, this FTP sends some data. Now, what transport layer will do? It will keep this data into the buffer. Now this buffer use a protocol called sliding window, right? Sliding window. Now how the sliding window works is like, and what is the use of this buffer, right? So what happened when the FTP sends some data to the transport layer, it will keep this data into this buffer, right? Until the it received by the consumer and consumer send the acknowledgement to you. Now how it works, for example, the FTP sends some two packets here, okay? So it will keep the data into the buffer here. Now this two packet will go from here to the network layer and to the transport layer of the receiver side. Now this is consuming and then it will say, it will send it to the receiver. Now this consumer will send acknowledgement. So as soon as the acknowledgement comes, this buffer will be free and the window move forward. Now here there's another thing is like, let's suppose this FTP is generating too much data. Now its buffer is getting filled very quickly. Now this buffer or this transport layer will send a pause message to the application layer saying that, hey, my buffer is full, please don't send more packet. Or let's suppose this application is sending a very less amount of data, right? It's sending very slow amount of data. This buffer is not 50% utilized, right? So it will say, hey, please send the data, a little bit fast to me. Now how this sliding window works is like this, okay? Now let's suppose this buffer size here is 7, right? So it starts from 0 to 6. Now let's suppose the application send 3 segments or 3 data to you, right? So it means the buffer has still how many space? 4 space left, right? 3, 4, 5, 6, 7. Now it will say, hey, to what application layer, saying that, hey, please send more data to me. So it will send a more data to this guy, right? Now here maybe its buffer is full, so its buffer is full. Now what it will do, it will say, hey, my buffer is full, please don't send much more data. Now during this time what will happen, the acknowledgement comes from the other side. Now what will happen when the acknowledgement comes, this one, like this one acknowledgement comes, so the window move forward and the window size remains 7, and there is a buffer left at 1, right? At number 7, you see, because here the buffer is full, it's waiting for the acknowledgement of the 0 comes, 0 move forward. Now there is some space left, so it will send to the application saying that, hey, I have some buffer left in my space or in my memory, please send some data to me. So that's how this sliding window works. Now in sliding window there are different type of protocols that work. So one is stop and wait. Stop and wait is like, hey, I have sent some data, it will wait for the acknowledgement timer to come, right? Or because I'm using, let's suppose this server sends some data, so it will wait till here till the acknowledgement timer comes. So this host sends acknowledgement, now it will send then again data. Now here both side, host side and receiver side, window size is 1, right? So it sends, wait, sends. Now what happened in this case, it sends here, it will wait here. Now let's suppose the acknowledgement come here, right? The acknowledgement come here. Now it will send again this same data. So this packet number 1, packet number 0, acknowledgement 1 comes, packet 1 goes, acknowledgement 2 comes, but 2 comes after this, right? After this one. So it will send again one packet. So imagine this is very slow, right? Because the window size is 1. Now go back and protocol resolve this problem by using a window on the sender side, but receiver side window is always 1. See, these all protocol built very in the 90s. They are not that much capable, but it gives us understanding what is we are going why the previous protocol did not work, right? So what I'm saying is like, hey, the receiver sender size, the window is, let's suppose, 7, but receiver size window is always 1. So here window size is 7, here window size is 1. What happened? It sends packet 0, right? Acknowledgement 1 come. Now here, this was the here, right? So it means the packet comes from the application. One packet comes, it keeps in the buffer and send it one. Now as soon as the acknowledgement come, this buffer is cleared. Now this is free, right? Now it the application sends 3 more packets, so it means it keeps all this packet into buffer, packet 1, packet 2, packet 3, right? But the acknowledgement one comes here by the receiver, right? Because receiver cannot accept packet 2 and packet 3. Why? Because its window size is 1. So what will happen? It will discard packet 2, packet 3 and send acknowledgement of only packet number 1. So again, this protocol is very slow. Now we have moved into the protocol called SRP, or selective repeat protocol. Now simple, it is very simple protocol. Just imagine like both the sender side and the receiver size window is same. It means here and here. So this is my sender, or I'll keep this sender on above of this sender, and this is receiver, right? So what happened? So it's here the size is 7. Here the size is, let's suppose, 7. It means I have the capability of accept 7 packets from the application layer. So let's suppose the application layer send 2 packets, right? So it means I'll send the 2 packets in a one go. Right? Now receiver will say, okay, I have also capability of receiving 2 packets, so it will receive 2 packets into its window. Now then it will send the acknowledgement of third packet. Why third packet? Because 2 packet it received into its buffer. Now once it's received into its buffer, it will send it to the application layer. See, we are talking here only about the transport layer. Now just imagine, always imagine this diagram. So it means I have 2 packets here, which is sent by application layer, TCP converted to the segment and send it to the TCP layer of the receiver side. Receiver side accept this 2 packet into its buffer and send the acknowledgement of third packet. As soon as the acknowledgement come, it will clear its buffer and it will send those 2 packet to the actual application layer of the receiver side, right? So that's how selective repeat protocol works. In this protocol, you should know what is, because here let's suppose, you know uh, I'll give you one example which will be clear you a lot of. Let's suppose here the window size is 9, right? So it means it has 9 packet into its buffer. Now but the receiver side window size is 7, so it means, let's suppose, if I have sent 9 packet, let me clear this stuff here, right? So it means if I have sent, let's suppose, 9 packet, so this is my packet number 1 or segment 2, 3, like that, 9, right? Now it means, but I don't have a buffer on the receiver side to accept 9 packet. I have the buffer size of 7 here. So what it will do, it will drop 8 and 7, right? 8 9 7 8 9, basically it will drop because it starts from 0. So it drops last 2 segments. So it means there is some mechanism should be there, so that the sender and receiver know, hey, what is your buffer size, right? What is your buffer, how much buffer size you have. Now to overcome this, we built a TCP, transmission control protocol. TCP will negotiate the window size between the sender and receiver. Not only that, it negotiate multiple other things which we are going to discuss in our next window. I hope you like this video. Thank you very much.